Hello everyone and welcome to another Eviews video tutorial. My name is Juan and today I'm going to be covering the topic unit root test with a breakpoint in Eviews. So let's begin with an introduction of the topic. So when we are performing unit root test, we should consider possible structural breaks in the series. And the reason for that is because in the presence of structural breaks, conventional unit root tests such as the Dickey-Fuller test are biased towards the non-rejection of a unit root. So in order to explain this a little bit better, I have here an example. What we are going to do is we are going to review the case of a discrete change in the mean of an otherwise stationary series. So what we're going to do in Eviews is we're going to generate an AR1 series, which is a stationary series, with a dummy variable for a discrete change in the mean value. So we are going to have here the variable yt with the lagged value of yt, so that would be yt minus 1. We would have a normally distributed error, and this gamma here would be the dummy variable, which is going to be equal to 4 starting from observation number 50 onwards. So let's go now to do this, generate this process in the Eviews and check what happens with the Dickey-Fuller test. So we are here in Eviews now. What we are going to do first is we are going to generate this scalar. We're going to type scalar, we're going to name it A1, and we say it was going to be 0.4. The second thing that we're going to do is we're going to generate the error term. For that we're going to type genar et, which is the name of the variable, the error term, and we're going to type nr nd, and that's going to generate a random series which is normally distributed. Now, the other thing that we need to create is a dummy variable. So we're going to click gen R, and here we're going to type dummy, and we are going to put 0. So now if we want the dummy, let's recall that we said that we would like the variable to start from observation 50 to have a discrete jump to value number 5, number 4. So what we're going to do now is click generate, and we see here in sample we're going to type 50 and we're going to type here 4. And what this is going to do now, if we check, is that all the observations are going to be 0, but starting at 50 is going to change to 4. So that's what we want. So now let's go and keep working. The next thing we're going to do is change the sample. We're going to start the first observation we put here because we would like to generate our variable y, which is going to start at 0. And the second thing is change back the sample from 2 to the last observation, and we are going to now generate our series. To generate the series, we're going to type series. We're going to type y. This value is going to start from 0, and then we had a1. We're going to multiply this times y minus 1 plus the error term. And here we have now our series, which is going to be that R1 that we just generated. We're going to click in the graph. And we get to see that now this variable is stationary variable. We can take a look at the correlogram quickly. We can see that there is no component in the autocorrelation that decays in a slow pattern, or we can even do the unit root test. We're gonna put no intercepts in levels, and what we can see here is that the null hypothesis is that y has a unit root, and if we check in the p-value, because it's smaller than 0.05, we reject this hypothesis, and we are clearly showing and working here with a stationary variable. So now let's modify this and let's include the dummy variable. Yes, I'm gonna type here dummy in my series. I'm gonna click enter, and let's take a look at now at our y series. So what we see now is that there is a discrete jump, yes, in what it would have been a stationary series. So the problem with this is that the real model would have a behavior like this. Yes, a good fit would be doing this and with this, But what Eviews is going to do, if we try to, for example, feed a linear regression, it's going to do this. Yes. So this representation is not correct, it's not accurate, and furthermore, if we check now in the unit root test, standard unit root test, augmented Dickey-Fuller with no intercept of trend, what we are going to see now is that, remember, my null hypothesis is that y has a unit root, and what we check here is that we cannot recheck this hypothesis. Yes, we cannot recheck it. So what we are saying then is that my variable would have a unit root. Yes, so this is what happens when there is a break. Yes, we're working with a stationary variable, but what we see there is that there's a break which is making a discrete jump in the mean value, and it's making our unit root test saying that the variable is clearly non-stationary. So let's go back now to our slide. So what are the possibilities when you see this? Well, one possible econometric procedure is to break the sample into two where we suspect the break. And then we would perform the Dickey-Fuller test in each part of the sample. So one of the negative things about doing this is that the accuracy of the results are subject to selecting the right break date. So to illustrate what I just said is we're going to break the sample into two. Let's begin with breaking the sample. We know that there was a discrete jump in the mean in the value 50, so let's go until the observation 49. And let's perform a unit root test in the variable now until the observation 49 and see what happens. We just leave none here. And what we can see here is breaking the sample into two. We know that until observation 49, the variable was stationary. And then what we can do is change the sample now again and do it in the second part. We know from observation 50 to 100 there was another piece that was stationary. We can take a look at y. We can click in the unit root test, standard unit root test, and now we're going to click an intercept because as we saw there was a jump, a discrete jump from 0 to 4. So this part of the sample would have that intercept change. We click in intercept, and again, as we see, the value is smaller than 0.05, so we reject this hypothesis of the unit root. So again, this clearly shows that before that break, this would be a stationary variable. So let's go back to our slide now. So the second possibility that we have is doing the unit root test with a structural break, as in Perron, 1997 specifically. What the author did was challenge the findings of Nelson and Plosser in 1982. So Nelson and Plosser, they indicated that most macroeconomic variables were characterized by unit root processes. So using the same dataset that Nelson and Plosser 1982, Perron results suggested that almost all of those variables were trend stationary with a structural break. According to Perron, most macroeconomic variables have a trend with a constant slope, but they present a sudden change, like for example in 1929, which is a change in the intercept, or the oil crisis of 1973, which would be a change in the trend. So the difference and the reason I put 1989 and 1997 is because Perron, his first paper, he selected the 1929 as a specific date, but in Perron 1997, his latest paper, the date of the possible change is not fixed like in 1989, but is considered as unknown. And the criteria to select the breakpoint date is going to be the minimum t statistic. That we are going to do that right now in Eviews. The sample that the author used was 1909 to 1970, and all these variables are in logs already. I'm going to open real GMP. Here we have the graph, and what we can see in this graph is clearly, this is the year 1930. So in 1929, there was clearly a break in the intercept. So we see the graph as this behavior, but because of this, it's going to be making our series non-stationary. So let's take a look then. What is the procedure that we would do is we click in view, we click in unit root test, and then we go with breakpoint unit root test. So here what we're going to do is we're going to leave it in levels. In the trend specification that we have here, we're going to select trend and intercept, And we know that what we can see in the graph, if there is a break in the intercept, yes, you could select trend. If, for example, you see that in 1929, it also changes the trend. It's upwards. Suppose it goes downwards, then you would be selecting the trend. But that's not our case. The breakpoint selection, remember I said it was the minimum t-statistic. Yes, Dickey-Fuller minimum t-statistic. And then the lag length that is going to be using the author, as in his paper, is going to be the f-statistic. Max lags, we're going to leave it at 10 as a default. We're going to hit OK. And what we can see here then, is that the null hypothesis is that my variable has a unit root. And what we see here now is that because the p-value is smaller than 0.05, we reject this hypothesis. Yes, this variable doesn't have a unit root and the break date that suggested was 1929, just as in the paper of Perron. Also the lag length, just as in Perron, it selected 8 lags based on the F statistic. And if we click here in this graph, what we're gonna see is that here we have the t-statistics value, and here the selection criteria is the minimum value, as I said before. So I hope that this video was helpful, and if you have any questions, please feel free to leave your comment. I also recommend you that you subscribe to my channel if you're interested in learning more topics related to economics research, things like latex, Eviews, Stata. I'm going to be submitting more content, so thank you very much for watching.